So it's my great pleasure to introduce Veronika Heimsbakk, if I pronounced that correctly.
Heimsbakk, yes.
Okay, great. Senior consultant in data science and AI insights and data at Capgemini, who will be talking about quite a hot topic in our space, SHACL. So over to you, Veronika.
Thank you, James. Okay, hello everyone, and welcome to this talk on how we can model requirements described in regulations with the Shape Constraint Language. My name is Veronika Heimsbakk, and I'm a senior consultant at Capgemini in Norway. I live right outside of Oslo with my fiancé and our two children, 3-year-old Edward and 1-year-old Oda. I got my degree from the University of Oslo with a specialization in logic and semantics. And of work experience, I've been touching into stuff like writing kernel models in C to semantic technologies applications in Java. I started off as a developer, but in 2019, I joined Capgemini, and here I'm working as a semantics nerd, information architect, and advisor. I have worked in several different industries, including oil, life sciences, public data, library, and media. I started working with SHACL in 2016, and yes, that is before it became a standard. And as all nerds, I have way too many hobbies, like making stuff, hunting, board games, and teaching kids to code, to name a few. So my current client is the Norwegian Maritime Authority, and all the examples you'll see today are actual data from our current project, simplified for the sake of examples, of course. So let us have a look at our simplified workflow of the semantics in the project. We have several different regulations in both Norwegian and English as PDFs or plain text. And some monkey, read me, identifying concepts and relationships using my highlighter pen in order to transform the data into an OWL-like ontology that works as a term bank. So it could just be a SCOS taxonomy, for example, and SHACL constraints for detailed instance modeling. We have a SPARQL query library that the backend uses for information withdrawal that goes through some processing before it's pushed to the front-end application. And currently, we have 2 projects running in parallel at the NMA. The first one is called APS, and a brief description of that could be automatic detection of requirements connected to certificates for sailors. And the second one is called ET for short, which describe metadata for requirements and make use of the graph as an information lake to ask for specific questions connected to the requirements. An example of a question could be, my fishing vessel is 8 meters long and it's built on January 3rd in 1998. Give me all requirements that apply for me in order to operate in Norwegian waters. In this talk, I'll show you examples from the APS project. So let us say we have a sailor that wants to become a master mariner. There are then 2 things you can do. First, you could use the SPARQL library to find all requirements needed for the master mariner certificate. This information is found in shapes in combination with the OWL-like ontology. And secondly, we could take the sailor's CV and requirement shape for this certificate, the master mariner certificate, as input. And output will be either conforms true if and only if he fulfills the requirements needed for the certificate, or confirms false if it does not. If the output confirms false, you'll get a report from the SHACL engine telling you what the instance data, the sailor's CV, is missing in order to achieve this certificate described in the shapes. So the data can look like this. And this is the regulation text. It's a plain text file where someone must identify classes, relationships, and data values by hand at the moment. This is me and my highlighter pen reading Norwegian regulation text and using the English version of the regulation to translate on the fly. We do actually have a proof of concept running right now to see if it's faster to identify these entities with natural language processing techniques. And I'm quite sure that NLP is much faster than me reading stuff in an unknown domain, as I had no prior knowledge of maritime data before I joined this project. So there have been a lot of funny misunderstandings of terms and concepts. So we're going to model things like this. So here we see paragraph 28, part 2, and its content describes requirements for gaining a Master Mariner certificate. And it says, in order to be issued a competency certificate, Deck Officer Class 1, that's the Master Mariner, in addition to the requirements in paragraph 23, 24, 25, 26, and 27, a minimum of 36 months seagoing service as a responsible deck officer on seagoing ships with a gross tonnage of more than 500 is required. Seagoing service is reduced to 24 months if at least 12 months are earned as a chief officer on a vessel of gross tonnage 500 or more. Long sentences. Anyways, as we see, there is a lot of information we want to keep from this short snippet of text. And there is also alternatives described here. The first alternative is a minimum 36 months as a deck officer, where deck officer is a superclass for all kinds of deck officer positions. The second alternative is minimum of 24 months as a deck officer, where at least 12 of those is served as a chief officer. And chief officer is a subclass of deck officer. So, how can we handle alternatives that includes a lot of different combinations and relationships? If we were to model this with the Web Ontology language, we sure would have to touch into OWL axioms and restrictions at some point. We also need to know if data is correct, especially when we are to compare instance data with regulation requirements. And OWL can only infer new facts in data, but it can't discover missing facts. And being able to understand OWL axioms and how OWL interpret data, you will need some understanding of discrete mathematics and logic. Well, my client are seafarers. Even though some players at the NMA are trained in RDF, that does not mean we should throw high complexity at the table just because we can. The data owners here are experts in their domain, which is seafarer, and not in semantic technologies. The main language we then chose for a graph is the Shape Constraint Language, a language designed for validating RDF under a closed world assumption. Unlike OWL, you can conform data to given data constraints with SHACL, which gives us the opportunity of checking a sailor's CV against a set of requirements to see if he fulfills a specific certificate or not. And the Shape Constraint Language are built up by shapes. And a SHACL shape is a collection of constraints for a given RDF resource. We have two kinds of shapes in SHACL. The first is the node shape that describe constraints about focus nodes, usually the subject of a triple, and property shapes describing constraints about predicates and object values of a triple. The definition of a node shape is that it is a shape that is not the subject of a triple where path is the predicate. In this example, we see a vessel shape that has a constraint on target class vessel. So all constraints following in this shape will have to do with instances of the class vessel. The definition of a property shape is that it is a shape that is the subject of a triple that has path as its predicate. In this example, we see a length shape with some path to vessel length. So for every occurrence of the predicate vessel length in any data, the constraints described here will apply to that triple. We can add property shapes onto a node shape using the resource property. Here we combine our two previous examples, stating that any instance of the class vessel may have some relationship called vessel length, pointing to, in this case, some random object value, as we haven't any more detailed constraints in the property shape. So there is a lot of constraints available in the SHACL core constraint vocabulary. And here is a brief overview of the main categories. And the nice thing about SHACL is that if you don't find a suitable constraint for your problem, you can extend SHACL with your own constraint definitions and push them to the web for others to reuse if you like. This is not possible to do with OWL, as the OWL vocabulary is limited to those resources set by the OWL committee. And SHACL contains constraints about value types as class affiliation and data type values, cardinality as min and max count of predicates, value range as min and max inclusive and exclusive, string-based as language checking, regular expressions and length, property pair comparing the object value of two predicates, logical constraints as not and or, shape-based as the property relationship we have just seen an example on. And there is also a collection of other constraints that doesn't fit into any of these other categories. And there do exist more categories apart from the core, like SPARQL constraints and SHACL advanced features, but I will not cover those in my talk today. I can post the link for the SHACL masterclass that was hosted yesterday. There are some links to resources and references on things beyond SPARQL core available there. So the main reason, or one of the main reasons we chose SHACL was because of the extensive SHACL core constraint vocabulary and being able to extend that if needed. Being able to model requirements containing alternatives as easily recognizable and or constraints is a great benefit for us at the NMA. Another reason is the verbose description of constraints that makes it easier for non-semantic players to read the turtle files. Unfortunately, there is currently no open source tool, at least to my knowledge, that let us visually create SHACL constraints as Protégé does for OWL. I know it exists a SHACL plugin for Protégé, but as far as I know, or at least last time I tried to use it, it was only a turtle code view inside Protégé and not the visual modeling tool that you know Protégé as. So we would have to stick with our editor of choice if we want to keep it open source. And SHACL is a validation language under closed wall assumption, meaning that facts that are not known to be true are false. And this is necessary for us in order to say something about our case for comparing CVs to regulation requirements. So let us take this example snippet from the regulation. How can we easily express the requirement that a vessel shall have a gross tonnage of at least 500? Well, like this. And here we have a property shape describing constraints for a given predicate. The predicate in question is the value of path, which is gross tonnage. We have a constraint that in a triple where gross tonnage is the predicate, the object value shall be minimum or equal to 500. We also have a constraint telling us the data type of this object value, which is unit GT, and a min and max count of 1. That means that the predicate is unique and mandatory for resources where it appears. If vessel has a relationship gross tonnage to some value, this specific relationship shall only appear once. At least once and not more than once. And here we see our solution on how to model the alternatives described in the regulation. As we remember from paragraph 28, part 2, there were 2 different alternatives. There are also some other options included in this OR constraint, and I'm going to talk you through it. So the OR constraint is a list-taking constraint that appears at the predicate position of a shape. This OR constraint takes in 2 AND constraints as its list elements. The first AND constraint are the first alternative. It takes in 2 items in its list. First, a OR list of courses, so at least one of these courses must be present for the whole expression to be valid. No, not courses, sorry, it's certifications. So a list of certifications, so at least one of these certifications must be present for the whole expression to be valid. And secondly, a specific value for a seagoing service. And we'll have a closer look at this seagoing service later on. The second AND constraints are the second alternative. It takes 3 items in its list. First, a OR list of certificates, and then a specific value for a seagoing service, and another specific value for a seagoing service. We remember from paragraph 28 that the second alternative was 24 months as in some position, where at least 12 of those months were in another specific position. And that is described in this second AND constraint. So let us look at the rest of the requirements in the snippet. We have information about duration, position, and a seagoing relationship, which can be some kind of trade area, the gross tonnage, and the gross tonnage that we saw in the previous example. And here are the requirements on the previous slide described as shapes. The first shape is similar to the one for gross tonnage, describing a minimum or equals constraint. The second states that the predicate in position shall be any instance of a deck officer position. At last, we have a property shape describing the predicate trade area to have a specific value of bank fishing. The class hierarchy with labels and relationships is found in the OWL light ontology at the moment. However, this information could as well be in the shapes instead. At the NMA, they already had a few OWL ontologies for their domain when I joined the project, but they struggled a lot with how to model the alternatives described in the regulation and applying information like min-inclusive on data values. And that is another of the main reasons why I propose to model requirements in SHACL, as it is so verbose and concrete. And for this case, on comparing CVs and regulation requirements, it's also the perfect case for SHACL validation. So let us put it all together for our first alternative in paragraph 28, part 2. We have a node shape describing the class value of this first alternative using the property shape constraints that we just saw. And some good annotation. Shape description is a must. And then we target the class that represent the first kind of seagoing service described in the paragraph, which is the value for target class. And at last, we connect the necessary property shapes with constraints that apply to this kind of seagoing service. Constraints for duration, position, trade area, and gross tonnage. So what SHACL really does for our models is it allows us to model data with a closed world assumption. This means that we strive for a completeness of our data, and we do not admit that we have any incomplete knowledge in our regulations. And that is the whole point of a regulation, isn't it? A regulation is a set of requirements for one specific subdomain of maritime authorities in Norwegian waters in this particular project. And it is important to remember that with the Web Ontology Language and the open world assumption, we can describe broader and more unknown domains that makes it easier to apply ontologies across various applications and domains. However, even though SHACL under a closed world assumption is probably most powerful locally, it is possible to reuse and share constraints across several applications, especially in combination with existing ontologies, using them as a reference for your constraints. If you're reusing SHACL shapes from another application, you have the possibility of deactivating shapes that it's irrelevant for your application and add new ones that apply in order to extend the shapes graph you're reusing. With SHACL, we can handle any constraint, and if we don't find what we need in the SHACL core, we can simply add it ourselves. You can even push your new constraints to the web for others to reuse. And SHACL is verbose and gives us detailed explanation of requirements, which is really handy for players with limited experience with RDF. And again, OWL and RDFS are splendid on inferencing missing facts. However, it is not detecting missing data, and that is what we need.
Would you like to go over to questions now?
Sure.
You'll be pleased to know it's been relentless, the number of questions, so I'll try and rewind back to some of the earlier ones. What are the hardware requirements to use SHACL as a validation language? Do you need a reasoner, data storage, etc.?
It depends on your application and what you already have, but you can do SHACL validation in memory if you like, without having to use a graph database. So you have several different SHACL implementations ready in frameworks for programming languages as Java, C#, and Python. I'm most familiar with the Java frameworks, and I know that the two most popular frameworks, which is RDF4J and Jenna, doesn't support the full SHACL implementation yet. But it's possible to use it for the most popular constraints in the SHACL core, and by using a programming framework, you won't need a database. There is also SHACL implementations in graph databases, as Stardog. They have a implementation of the SHACL core constraints, and also Top Quadrant actually have a full SHACL implementation, including the SHACL advanced features. And that is probably because one of the employees at Top Quadrant is one of the leading developers on this standard. Yes. Apart from that, I don't know if I see there was a question on Neo4j or AWS Neptune. I'm not familiar with if Neo4j has an implementation of SHACL. I'm not sure because Neo4j is operating on other data than RDF. It's on labeled property graphs and not semantic knowledge graphs. But I know they try to map their labeled property graphs onto RDF and vice versa. So if there exists some SHACL implementations in Neo4j, I don't know, but it would be funny to see.
Yeah, I shared a link. So they have an implementation of SHACL, but I think it relies on transforming RDF to label property graph, and then it's part of an internal kind of Java plugin. I think some of the validation functionality. There was a question or some points around SHACL C versus SHACL. I'm not sure whether that's a thing. Maybe you might want to elaborate on. I don't know whether that makes any sense. I'm not familiar with SHACL C.
No, not me neither.
No,
I'm sorry.
maybe it's a typo. Okay.
But it may look like shape expressions that has been kind of a schema language for RDF prior to SHACL, but I'm not too familiar with that. So
someone commented SHACL compact syntax is
okay.
Okay, that's useful.
So that has to do with JSON LD probably, because that can be compacted quite a bit.
Okay. There was another question about whether it's possible to model. You may have already answered this, but whether it's possible to model SHACL constraints completely via SPARQL queries.
Yes, all SHACL constraints can be translated to SPARQL at least. And I'm not sure if you can do it the other way by constructing SHACL from SPARQL. I haven't tried it. But in the SHACL documentation on the W3C domain, every single shape constraint has a SPARQL definition as well. So you can go in there and look on the SPARQL definition for every single constraint. I'm sure it probably is possible to turn it the other way around as well if you want to construct shapes using SPARQL.
Okay, great. There was a question also from Vladimir Alexiev asking, Veronika, have you considered generating SHACL from a briefer logical notation? Your rules are reminiscent of Prolog.
No, I haven't considered that, but I'll bear it with me. Thank you.
Cool. Maybe guys can connect in the Slack channel later. Great. Are there any other questions? I can see a few people typing, so I'll just check back through the history of the questions whilst those are coming through. I guess whilst those questions are coming through, I have a real affinity for the kind of language challenge in shipping. So we do a lot of work. My company does a lot of work in shipping, and the language is particularly unique, isn't it?
Yeah.
And there's very little in the way of kind of industry standards, particularly kind of ontologies, or at least from what we've found anyway. So I guess I was interested in how you're applying SHACL for kind of unstructured versus structured data, like whether you're using SHACL for, you touched on kind of maybe some opportunities around NLP and
yeah.
yeah.
Yes, the NLP proof of concept was started because I didn't bother to spend too much time on reading the regulation text. It's about, I believe, around 70 regulations in the Norwegian Maritime Authorities, and translating manually one text to ontology or to SHACL shapes by hand took probably around a week. So that's time consuming and expensive for my client. So we wanted to try out to see if we could make use of some simple NLP techniques to draw information from the text. So we have actually successfully generated all scope descriptions and requirement descriptions connected to those scopes. And one scope could be like a value range for vessel length, or a date before and after one certain date, or machine power, and a lot of different things are scopes in the text. So we successfully do that now. And the most challenging task around that is classifying entities discovered in the text to be of kind, material, or construction or equipment and stuff like that. Yeah. The proof of concept is still running. It's supposed to be finalized during December, and hopefully we will get the result that we want, which is the class hierarchy or taxonomy, including labels and the shapes describing requirements and scopes for the data.